My dear students, now we are going to discuss some problems on jet transform. First of all, let us take one problem. In examination point of view, the problem is asked like this. We'll ask like this. That is, determine the jet transform. Determine the jet transform and ROC. As we know that ROC is region of convergence. Okay, ROC of the following signals. So in the first, let us take the signal, that is x of n is equal 1 by 2 over n into u of n. And the second one is x of n is equal 1 by 3 power n into u of minus n minus 1. Okay, if the problem is like that, let us discuss. And one more, let us take one more example for the jet transform. So in this example, we are going to take two terms, that is x of n is equal to 1 by 3 power n into u of n minus 1 by 2 power n. Wait a minute. By 2 power n into u of minus n minus 1. Okay, for these three bits we are going to find out jet transform and whose ROC. Okay, let us take a first one. What is the first bit? X of n is equal 1 by 2 power n into u of n. Solution. First of all, let us find out, for the given sequence, let us find out the jet transform. You know that a jet transform equation, that is the jet transform equation, that is equal to x of z is equal to summation n is equal to minus infinity to infinity x of n into u of n. What it is? X of n into z power minus n. Z power minus n. It is a generalized equation. So let us substitute x of n. Summation n is equal minus infinity to infinity. In place of x of n, we are going to write down 1 by 2 power n into u of n into z power minus n. Okay, here we have the u of n. We know that u of n is a unit step function. Here unit step function, that is in terms of discrete. How we are going to draw that unit step function? So whose amplitude value is 1 for n is greater than or is equal to 0, and so on. N, and this one is E of n, whose amplitude value 1. E of n is equal to 1 for n is greater than or is equal to 0. 0 for n is less than 0. So based on that, this limit that can be changed like this: n is equal to 0 to infinity 1 by 2 power n into z power minus n. This one is 2. Okay. Now we are going to write this entire one in terms of alpha power n. So that is n is equal to 0 to infinity 1 by 2 into z whole power minus n. So in terms of alpha power n means this one, it is z power minus 1. Okay, it is look like alpha power n. We know that summation n is equal to 0 to infinity alpha power n is equal to 1 by 1 minus alpha. We know that. So therefore Z transform of the given sequence x of n, x of z is equal. So according to this, here this entire one, consider this one is alpha. So as per that, we are going to write it as 1 by 1 minus 1 by 2 z power minus 1. It is Z transform, which is represented by x of z. So from this equation, let us write down the ROC. Here what we have, Z inverse. For example, if we substitute Z inverse, means how we are going to write it as that Z inverse is also write it as 1 by z. Am I right? Right. So here the ROC of this one, ROC is simply ROC is mentioned in terms of z value, that is magnitude of z. Magnitude of z greater than 1 by 2. Why? Because it should not 0, denominator value should not 0. So for making that, we are going to take like that. Why? Because for example, if z value is 1 by 2, let us consider z value is equal to 1 by 2. What happened by substituting that? So x of z is equal to 1 by 1 minus 1 by 2 1 by 2 inverse. What happened? The denominator value gets 0, so should not 0. So that is the reason here the mod z value greater than 1 by 2. It is ROC. In this way we are going to find out Z transform for a given x of n. Now let us do the second bit. So in the problem, second bit, what is that second bit? So this one is the answer for the first bit, and the second bit, what is that second bit? X of n is equal to 1 by 3 power n u of minus n minus 1. X of n is equal to 1 by 3 power n into u of minus n minus 1. Okay, solution. So for this also we are going to find out x of z and ROC. Okay, let us write down the given. That is x of n is equal x of n is equal 1 by 3 power n into u of minus n minus 1. Let us write down the equation formula to find out the Z transform for a discrete time signal, that is equal x of z is equal summation n is equal minus infinity to infinity x of n into z power minus n. Here we have three valid Z transforms, so based on the range of n. So the first one is x of z is equal summation n is equal to minus infinity to infinity x of n into z to the power of minus n. It is a two-sided sequence and a single-sided sequence in terms of that x plus of z, which is equal summation n is equal to 0 to infinity x of n into z to the power of minus n. And one more one-sided sequence, so based on the n range, that is equal n is equal minus infinity to 0 x of n into z to the power of minus n. So these three are the valid Z transforms. But here what we have according to the given, here we have the u of minus n minus 1. Okay, let us substitute that x of n in this formula. N is equal to minus infinity to infinity. In place of x of n, we are going to substitute 1 by 3 power n into u of minus n minus 1. Okay, into what we have, z to the power of minus n. Okay, so here it is u of minus n minus 1. So that is exact mirror part of unit step function. It is starts from n value minus 1, here from minus 1 onwards. So that is, it is also discrete, minus 1 minus 2. So u of minus n minus 1 means from here onwards it will start, whose amplitude value 1 and so on. So for this we are going to simplify the given one according to this. This one is simplified as summation n is equal minus infinity to, in the brackets we have minus 1, so minus infinity to minus 1 by 3 power n into z to the power of minus n. So this one is also right in terms of alpha power n, that is summation n is equal to minus infinity to minus 1 by 3 into z to the power of minus 1 whole to the power of n. Okay, now let us change the limits, that is minus infinity to 1. So which is write it as 1 by 3 z to the power of minus 1 whole to the power of minus n. Now let us interchange the limits of the summation. By interchanging the limits of the summation, what we will get? We will get summation n is equal to 1 to infinity. Wait a minute. N is equal to 1 to infinity 1 by 3 power minus 1 z power n. Okay, so from it is look like alpha power n. So for this it is the limit of n value, n is equal to 1 to infinity. So we know that summation, summation n is equal to 1 to infinity alpha power n is equal alpha by 1 minus alpha. In the previous example, where the n range from 0 to infinity, at that time for n range 0 to infinity of summation, alpha power n is equal to 1 by 1 minus alpha. But here n value from 1 to infinity. So alpha power n, when the n value from 1 to infinity, whose solution alpha by 1 minus alpha. So in place of alpha, what we have? 1 by 3 inverse of z. Okay, let us write down that. That is x of z is equal 1 by 3 inverse of z divided by 1 minus 1 by 3 inverse of z. Okay, here 1 by 3 inverse, how we are going to write it as, which is also write it as 3 1 by 1 by 3 z by 3z by wait a minute. Okay, so 3z by 1 minus 3z 1 minus 3z. Let us simplify that. X of z is equal 3z by 1 minus 3z. Let us take 3z as common in the numerator and denominator. What we will get? 1 by taking 3z common and get cancel, we will get 1 by taking common, what we will get here? 1 by 3z minus 1. How we are going to write it as, which is also written as minus 1 by దీన్ని ఎట్లా రైట్ చేసుకోవచ్చు, దిస్ వన్ ఈజ్ ఆల్సో రైటెడ్ యాజ్ 1 by 1 minus 1 by, actually this minus 1 is 1 by 3z minus 1. So 1 minus 1 by 3 into z inverse, what it is, which is x of z, x of z. What about ROC for this? ROC for this one is mod z value is less than 1 by 3. In the previous example, the first one, so in this case, what about mod z value in the first example? What it is, the first example means first bit. So in the first bit, mod z value greater than 1 by 2. It is in the numerator 1 by 1 minus, but here it should be less than 1 by 3. Then only the denominator should not 0, otherwise so this one, therefore x of z is equal minus 1 by 1 minus 1 by 3 z inverse, and ROC is mod z less than 1 by 3. Okay, now let us do the third one. What is the third bit? In the third bit, x of n is equal 1 by 1 by 3 over n into u of n minus 1 by 2 over n u of minus n minus 1. So it is a given. Now, so let us substitute that x of n in the formula of Z transform, that is x of z solution. Here also we are going to find out x of z and ROC. So here the formula is n is equal to minus infinity to infinity x of n into z to the power of minus n. Okay, so now let us substitute in place of x of n, let us substitute the given, that is summation n is equal to minus infinity to infinity 1 by 3 power n into u of n minus sorry for the delay, minus 1 by 2 power n into u of minus n minus 1. Okay, so let us into z power minus n. So let us apply the summation for both the terms individually. Why? Because where here we have the u of n and here we have the u of minus n minus 1. So limits will change. Okay, summation n is equal to minus infinity to infinity 1 by 3 power n into u of n into u of n into z to the power of minus n minus summation n is equal to minus infinity to infinity 1 by 2 power n into u of minus n minus 1 into z to the power of minus n. Okay, and now let us change the limits. Here we have the u of n. So for the summation n range from 0 to infinity. Why? Because it is unit step. Infinity 1 by 3 power n into z to the power of minus n. Next, here we have the u of minus n minus 1, whose limits that will change like this. Summation n is equal to minus infinity to minus 1 1 by 2 power n into z to the power of minus n. N is equal to 0 to infinity 1 by 3. Let us write down this term in terms of alpha power n, z to the power of minus n minus 1 whole to the power of n minus summation n is equal to infinity to 1. Now first of all let us write down as it is, and after that we will change. Okay, summation n is equal to minus infinity to minus 1 by 2 1 by 2 1 by 2 power n. So which is also write it as alpha power n. So for that, into z power minus 1 whole to the power of n. Sorry for the delay, due to inconvenience, very sorry. Okay, power n. Let us simplify this. So let us simplify the second half part. Because actually it is not a valid Z transform. That is the reason. Summation n is equal 0 to infinity 1 by 3 z to the power of minus 1 power n minus summation n is equal infinity to 1 1 by 2 z power minus 1 whole to the power of minus n. Okay, now let us make the second part to alpha power n. So for that, summation n is equal n is equal 0 to infinity one by 3 z power minus 1 whole power n minus summation n is equal to 1 to infinity 1 by 2 power minus 1 z whole power n. Okay, so in the first part what we have, it is look like alpha power n and n range 0 to infinity. We are going to write it as 1 by 1 minus alpha, that is 1 by 1 minus 1 by 3 1 1 by 3 Z inverse. Likewise here what we have, minus of minus, minus of minus plus. Why? Because this part is look like the previous example. So for that what we will get, minus 1 the second part, minus 1 by simplifying that, what we will get, minus 1 by 1 minus 1 by 2 Z inverse. By 2 into Z inverse. By 2 into Z inverse. So which is write it as 1 by 1 minus 1 by 3 Z inverse plus 1 by 1 minus 1 by 2 Z inverse. Minus 1 by 2 Z inverse. For these, mod Z value lies between, so mod Z value greater than 1 by 3 and less than 1 by 2. So it is a ROC for the given sequence x of n, ROC of Z transform for the given sequence x of n. Okay, thank you.